In this video, we're going to learn how we can use Avogadro's number to determine how many particles are in a substance. So recall that 1 mole of a substance is equal to 6.02 times 10 to the power of 23 particles of that substance, or 6 sextillion particles. This value is known as Avogadro's number, and it's represented by a capital N with a subscript capital A. And it's named in honor of Avogadro, the man who discovered the concept of the mole. So to find the number of moles of a substance, you use the following relationship. So little n is the symbol for moles, and it's measured in moles. And that's equal to big N, the number of particles, divided by big N with a subscript big A. That's Avogadro's number. So if you're more familiar or you're more comfortable using this relationship, because you'll need to possibly rearrange this formula, then you can use this. So the big N, like I said, is the number of particles. It's found at the top of the triangle. Moles is little n, and it's found right here, and it's measured in moles. And then the big N with a subscript A, big A, is Avogadro's number, and that never changes. No matter what substance you have, if you have a mole of that substance, you will have 6.02 times 10 to the power of 23 particles in each mole. And it could be, if you're measuring molecules, then it would be that many molecules. If you're measuring atoms, it would be that many atoms, and so on. So that's why we call it particles. We're not quite sure what we're measuring until we're measuring it. So to use this triangle, you would cover up the value that you're trying to find out, and then you would look for the other things. So imagine you're trying to find out the number of moles. So here we would be trying to find this. Then that would be equal to big N over big NA. So if the substances or the variables that you're looking for are on top of each other, then you divide. So you would put the number of particles in first and divide it by the number of Avogadro, so Avogadro's number. If you were trying to find the number of particles, which is often what you'll be asked to do, you would cover up the big N right here, and the two variables that are remaining are side by side. So when in these relationships, if the variables are side by side, you would multiply. So the number of particles would be equal to little n times Avogadro's number. In our first example, we're being asked to find the number of molecules in 2 moles of hydrogen. So if we take a look at our triangle down here, we want to find out this variable right here. So we want to know the number of molecules, so the number of particles. So if we covered that value up, we would multiply the number of moles, which we know, and the Avogadro's constant, or Avogadro's number, which we always know, and then we can find out the number of particles. So if we write out that relationship, so we want to find out big N, and that's equal to little n times Na. And we know that little n is 2.00, and we know that Avogadro's constant is 6.02 times 10 to the power of 23. So I always like to take a look at the relationship and then figure out what I'm looking for and write the other values in. So we'll plug those numbers in. So we know that little n is 2.00. We're going to multiply that by big NA, so 6.02 times 10 to the power of 23. And if you put those values in, you would get this as your answer, 1.20 times 10 to the power of 24. So for solving these types of equations, you will need a scientific calculator, one that has scientific notation, and you need to become comfortable with performing calculations using scientific notation. In our next example, we're being asked to find the number of moles in 1.20 times 10 to the power of 25 molecules. So the value that we don't know is n, so that's our question mark. We know big N, that's 1.20 times 10 to the 25. And we always know Avogadro's constant, 6.02 times 10 to the 23. So to calculate this one, we cover up the value we don't know, so this one here. So the remaining two would be big N divided by big NA. So we'll start to solve that. So little n equals big N over big NA. So we put those numbers in. So we have 1.20 times 10 to the power of 25 divided by 6.02 times 10 to the power of 23. And you should get a value of 19.9 moles. Now, if you're not sure if you performed the scientific notation correctly, you can go backwards and solve for whether or not you get 1.20 times 10 to the power of 25 particles if you multiply your number of moles with the Avogadro's number. So it's not a bad idea to check your work and make sure that you can go back and get the same value as you started with.